saying is where my research into how mind fits into physics has got. Well, first of all, let me say that I think there's a need for new physics because, as was mentioned a little while back, there are a few clouds on the horizon with regard to ordinary physics. The standard model works well as far as it goes, but there are things beyond the standard model. There's also the fact that standard quantum mechanics doesn't give a realist view of nature. One would like something which talks about what is happening and not just gives a statistical view. And if you look in statistics, you may end up not noticing what's going on. If you averaged all the conversations or all the lectures, you just get a mess, and you would miss the fact that something meaningful was happening behind the statistics. So, a number of reasons for going beyond the current consensus view. I should say that this is, in a way, not really my own work. It's more a synthesis of what other people have been writing. A lot of people have been saying ideas which are all along similar lines and consistent with each other, but I'm not sure that anybody has produced a sort of total picture saying that this is how it all fits together, which is what I'll be trying to do myself. So, oh yes, there's also a problem of quantum observation, which is, well, a dozen different views as to what's really happening with quantum observation. Collapse, many worlds, transactions, and so on. That's another problem with the conventional view. Anyway, the simplest approach, I think, sort of to ground what I'm saying, is to say that one can work with a generalized life. We're familiar with the phenomenon of life, that's the subject matter of biology, but that is really a special case. Chemistry depends on chemistry to a great degree, in addition to which it's extremely complicated, and issues like how does it really work and so on. So it might therefore be good to look at life from a more general point of view. And well, I think at the end I got a sort of listing of the different approaches, but one particular approach that I found useful is that of Karen Barrard, who has a book called Meeting the Universe Halfway, The Entanglement of Matter and Meaning, and she talks about a gentle realism, which is the idea that agency, which I'll be defining in a moment, is the foundation of things, and agencies work together to produce phenomena. But anyway, one can use this to unite three different perspectives, those of physics, biology, and semiotics. And I guess people here are most familiar with physics, and I would say the defining feature of physics as we normally understand it is its use in mathematics. It works in mathematical models, you do computations and you verify your theories that way. But biology obviously is something rather different. Biologists don't normally do the precise computations of the physicists, except when physicists get to work on particular phenomena. But they mainly focus on processes and how things all fit together, processes and organization. So in biology, one approaches the problem of understanding nature in a totally different way. And then something which many of you may not be familiar with, it's something physicists don't talk about, and that is the subject of semiotics. And maybe you haven't even heard of the word. Semiotics is the means the science of signs. And it originated in the 19th century with the work of philosopher Charles Sanders Peirce, and studied signs and how they work in great detail. And signs are like information, and physicists, especially quantum physics, have started considering information as something very important. But signs are something different, and the major difference is that you could say that information is interesting because it goes from one place to another. So two things are involved, the source and the receiver. Whereas versus semiotics involve three things: the sign, the object that it relates to, and the interpretant. The interpretant is the process that links the two and does the interpretation. And that makes the whole thing rather different. And we might bring in the idea of one of our collaboration, Alex Hankey, who's here. Alex mentions the difference between linear and non-linear. And information transmission tends to be a linear process, whereas semiotics is very non-linear. So you could say this is about where non-linearity fits into physics. And so regular physics, which is what you have in the regular physics journals, is really incomplete without the other two, but it hasn't really, they may consider things you can ignore. Like physicists would say biology is just for biologists to study on. We can perhaps contribute to help in certain ways, but it's not the main concern of physics, how life works. Again, semiotics, well, people might be interested in linguists and so on, might be interested in science, but it's not really the business of physics. We just deal with information. But I think in new physics that will not be true. I will show how it works together. And as I said a moment ago, Barrett's concept of agency is a way to bring them all together. And just to say a bit about her approach, it is a development of Bohr's philosophy. But she criticizes Bohr, and she says Bohr focuses entirely on the meaning. There's ontology and the other thing. Biology was concerned with. Bohr was concerned with knowledge, what we could know about reality, not what reality was. He said we can't really know what reality was, whereas Barrard is concerned, like most of you here, concerned with what is actually going on. And Barrard says we can go beyond Bohr by taking the phenomenon as a criterion for objectivity. We can agree certain phenomena occur, even if we're not too sure how to talk about them. And phenomena are the result of agencies working together. That any gadget in an electronic circuit, that one designs an electronic circuit because of the phenomenon it exhibits, which one wants to happen. And that comes about because there are a lot of agencies, in this case, say the transistors and the connecting wires and so on. These all work together to produce the phenomenon. So I'll consider agency as something that can be characterized in some sort of mathematical way, or some formal way, like a Turing machine. And it features in explanations of how something works. Once one has something in more or less mathematical form, one can then explain the phenomena that arise just by doing the mathematical arguments. Now, it's one point that's important, and this is where the biology comes in that human designs are, one might say, mechanistic. Biological is not a point emphasized in Robert Rosen's book, Life Itself. In other words, you can write down an explicit statement as to what your agencies do. In in the sort of thing that human beings design. Whereas in biology you can talk about some process like balance, and balance is something that changes from time to time. It develops and improves. So that's the additional thing. Agencies work together, but they work together in the service of the whole, which is the point which Ballard makes. They don't interact in the usual way. There's interaction, action within the phenomenon. Another way to talk about it is that there's a top-down element, that the parts work together to produce the whole, but the whole then feeds back to produce the individual phenomenon. So that's the kind of aspect of it. Let's see, I have to put in semiotics here. I simply say that the parameters that you have in your mathematical description may be things which control the sense of meaning, but anyway, I'll be getting to that in a moment. So the point I want to make here is in biology you have very specific forms which are fairly universal, like well, balance is one, vision, and so on. And new biologists will talk to you about the particular processes that go on in biology. And there's a very general schemes which have units which are invariant from one species to another. So now you do have these general schemes also in physics. For example, crystals have the feature of periodic lattice. But in biology things are a lot more complicated. These schemes are amazingly complicated. If you go to a lecture on biology, you'll be amazed at all the detail that's there. So one may ask, why is biology like this? And the answer is that for an organism to survive at all, it has to do specific things, and it's difficult to do them. That's why you have complication of machinery, so it's rather forced on organisms to be complicated. If they were less complicated, they would just not continue. So this leads us to a problem as to why can this happen at all. This is the origin of life problem. I think the answer to it is to generalize biology, as I said in my introduction. Our usual vision of biology is or life is the kind of life we see all around us. But perhaps there's something more general, which doesn't depend on chemistry or these complicated, very specific molecules and so on. And this might be useful to see if there's something more complicated. And once it's more complicated, it can perhaps get, if there's a simple form, it can perhaps evolve to become gradually more complicated. There's a good illustration of this with weather. It actually has a fairly simple basis, the equations of fluid dynamics and so on. But that does feature various kinds of phenomena. And we recognize in this phenomena like hurricanes and so on, anticyclones, clouds, I suppose. They're there because they survive. So the weather itself is illustrating this point, that there are these forms which survive in a way that organisms survive. So where can we get from there? No, I think I didn't have time to make many slides, so I'll fill in here. Let's see if I can go down. Oh, actually, I'll go over here. The point one has in systems like weather and, well, all sorts of systems are they're emergent systems like these weather phenomena, and these have their own dynamics. So it's really a mathematical pattern that emerges from deeper mathematical patterns. And one thing which is characteristic about life is these processes that start and then stop and then start again. So there are intermittent movements, and you can easily model this by having a control parameter that can turn the activity on and off. So when you adjust this parameter, the system may become unstable and this activity starts up. And then the parameter changes again and the phenomenon will die out. But conditions for the phenomenon are just there. You just have to adjust the parameter so it can start and stop. Right, let me just see what yeah, well, I'll get back to evolution in a moment, but let me say that this is where the semiosis or signs come in, because I talked of a parameter which can turn the system on and off. And that parameter is doing just what we expect from a sign. If you want somebody to do something, you tell them to do it, and that sign then starts the process up. But also in biology, there's a whole field now. Biologists accept semiosis, or some do, even though it doesn't feature much in physics. And there's a whole discipline, biosemiotics, which is viewing biology from the point of view of science, and this helps you understand how organisms evolve and the role that science play. One particular point is that a sign can evolve its meaning. It may mean something at some stage, and then you learn to respond to a situation in a different way. So signs are a way that facilitates biological evolution. So, and this is how language works particularly, because we use the fact that words can be put together in indefinitely many ways and still have a meaning. These amazing tools. The individual words have a meaning, or they refer to something, and then you can put them together to drive a complex situation. But there's no fixed meaning. The point that Barbara pushes, it's emergent meaning. As language evolves, people simply find ways in which language can be used, and there's no fixed specification of what words mean. So again, we have this flexible evolution. Yes, one point I'll make is that I talk about simple systems, like simple weather systems, which where there are some parameters that can turn on and off. Well, you can imagine you have two dynamical systems, and one dynamical system can, through its dynamics, turn another system on, and this way you might get a whole complex of systems which can interact in complicated ways. So this provides a way in which simple mechanisms could evolve to do more complicated things. Now, what are the criteria for this process to work? Well, we can talk of this in terms of the concept of life strategy. You could say that different species differ because the more advanced species has developed a new strategy. For example, locomotion, the ability to move in a controlled way from one place to another, is a strategy which some kind of organisms don't have. Well, trees, for example, don't walk from one place to another, whereas I think bacteria do move around in search for food. So that's an example of a new strategy, and that strategy could be implemented in many ways. So one way in which evolution works is at some point you have a new strategy is developed. Some mutation produces a single organism that can exploit this new strategy, and evolution will work in its favour. And then that can generalize. It can be the strategy can be implemented in ways which are more flexible, and so on. So that's again a general theory. Now you may say, aha, you've missed out reproduction. Without reproduction you can't have natural selection. Well, the point here is that reproduction may go in the same way that the life goes on. It doesn't have to be the advanced process involving replication of DNA, which is a very powerful system. All you need for reproduction of an organism is for that organism to be able to make a copy of itself, which might happen in various ways. So reproduction then needed to get natural selection may be something very simple which gradually becomes more elaborate. So that basically is the idea, and I sort of defined a simple form of life, which is illustrated by weather phenomenon. I've talked about some mechanisms by which it could become more and more advanced and complicated, but now you say, well, that's all very well, but that's a separate discipline. What's it got to do with ordinary physics? Well, one could make a connection by postulating that this basic or deeper form of life might set laws of physics as a means of survival. So this implies some ability to control nature, but once you have a language system which can refer to what's going on, that can be used to control what's going on. We do that all the time, setting regulations. So one kind of thing that can happen with enough steps of evolution is you will have a system which can exert more and more on nature and produce a subset of nature which looks like our ordinary world. So there's no difficulty in principle to make physics in this. So this is a kind of project for the future, and it may very well link with the more conventional ideas. Well, as I say, the idea is more related to the way physicists go about their work, which have been talked about at this conference. And hopefully the use of cross-fertilization between two, as yours becomes more biological, and this approach becomes more physical. Well, now controversial bit. Is this the last slide, or apart from my sources? Well, it has a controversial case which might get thrown out of the room if one said it in the wrong place, because actually one possibility is that if this system can control laws of physics, can also have a role in the evolution of life. And that would provide a mechanism by which intelligent design could work. And there's no proof as such that that ordinary neo-Darwinism will work. There are no numbers, it's not physics. And if somebody did a computation which really showed that human life would evolve without having to suppose there being information fed in from a different level, fine, but these numbers are not done. It's what Popper called promissory materialism. So it's quite possible that the basic intelligent design concept is correct. Also, well, less controversial things, but phenomena which may be explained by this approach, which cannot be explained by the conventional approaches, and these are human activities, and I'm referring particularly to mathematics. I don't agree entirely with Penrose's idea, because I think he has a simplified model of how brains work. But the fact is that we don't really know how we do mathematics or even thought. It's the idea that you simply generalize things without any inspiration coming from another source. In particular, how you do things like advanced mathematics. I don't think we have any kind of explanation from conventional sources. we don't necessarily, I don't think we necessarily have an explanation of how thinking works. Thinking is a fairly reliable process on its own, and I don't see much in the way of models. I mean, artificial intelligence people can model it with programs, but how did we evolve these programs? So I suspect the truth of the matter is that evolution at this deeper level of physics produces efficient systems because of their biology, and human beings have the ability to connect with that level, and that's how a subset of people can have the inspiration to do mathematics. Similarly, I think for music, I once wrote a paper in collaboration with a musicologist arguing that we don't have any very good explanation for musical aesthetics. I mean, you can say these brain systems involved, but that doesn't show why a particular musical forms with their power. So again, that might involve vibrations being part of the mechanism at this deeper level. Okay, that's about as far as I've taken it. I think this combined with what new people are doing can be the foundations of new physics, which may actually, as I said in a lecture elsewhere, as much emphasis put into this as into string theory. It's really going to go on. Okay, I'll just finish by putting some of the sources I mentioned. This is Karen Ballard's book, quote for another talk. I got some quotes to introduce the lecture. Matter and meaning are not separate elements, they are inextricably fused together, and no events can tear them asunder. Circular theory, that's a curious situation. Someone called Alexa Yardley contacted me about 10 years ago with very strange sounding ideas, but people who've seen the writings have felt there seems to be something in them. Until you really understand her line of thinking, it's difficult to understand what she means. But here's an example of what's in the book. Somewhere between mind and matter is an expression we normally call symbol. Well, she talks about mind being the hidden part of reality and how they connect and the symbols connect them. A lot of these works, and we know symbols exist because we see them. And then connections, I didn't mention idea except, well, I talked about strategies for life. That's really ideas. Ideas, symbols, and symbols, mind. Symbols articulate mind, and there can be no mind without an idea without symbol, so on. So here's a lot of trios. Some connection between her work and Pierce, by the way. And I'll just give a link to Alex Hankey's paper, which is something about how life organizes itself, and then some elements of this here. Or you can just go to philpapers.org and search for Hankey and you'll get it there. So, okay, to conclude, I'm talking about the understanding of life of a more generalized kind, which does not depend on chemistry. And once you accept that, interesting possibilities open up, as I've been describing. Way to summarize ideas is agencies can have a life of their own. In fact, there's a book called Biosemiotics by Hoffmeyer, who has a subtitle, The Life of Signs and Signs of Life. So, that's it. Thank you very much.
Thank you, Professor. Thank you very much.
Question here.
I'll answer questions
I have a question.
if
I don't know much about semiotics. Could you correctly say that steam is a sign pointing to a phase change in water? Would that be a proper example? Excuse me.
I'll just say memory of water is a very interesting thing, which may be an example of this kind of life. But I'm not sure how you'd increasing my height. I don't quite understand how it's connected with phase changes.
When steam usually occurs from water, so that's a phase change. So would steam be a sign pointing the way to a phase change in water? I'm saying totally
yeah,
ignorant
so
of semiotics.
no, it's not really the way it's used. I mean, well, biosemiotics started because, just the use of language as an example of the power of sounds. Biologists tended to think it's only applies to humans. Humanists weren't concerned with the biological aspect, so all put together. It's merely that once you get into the meaning aspect, then all sorts of things come out. Peirce had a quote that the universe is pervaded with signs, but they don't just sort of transmit from place to place. Signs do things, but there has to be something that does, I think.
Thank you.
Could you say a bit more about the context within which you would see systems involved in actually producing physical laws?
Well, I haven't thought about detail, I only about the principles, point is physical laws allow you to exploit physics. I mean, we make things with physics. So it's an advantage if things have an orderly behaviour. So the idea would be that would in some way assist these forms of life, but I don't really not too clear what the details are. Well, actually one thing would be memory, because it's some equivalent to brain that you want yes, you're going to be building up structures which do these things, and so physical laws might help to stabilise those structures, for example. Might actually come out of things like symmetry principles.
I had thought you meant something like the biological interactions stabilize and produce worlds for those biological entities. Their worlds have physical laws in them, so that the physical laws that are coming out, physical laws for those entities.
Yes, that's what I meant, yes.
In that way.
Yeah. Yeah, that's what I had in mind. Because, we're sort of exploiting physics all the time, and this is just a larger scale version of it.
Brian, this is a comment on which you might like to further comment. As I see it, your basic perspective on the universe we experience is that life, mind, and intelligence, together and separately, play fundamental roles in the whole structure of creation. And what you're looking for, as I see it, particularly clearly after this lecture, it seems to me, is that we should be able to identify fundamental principles that actually underlie not only physics, but also these other three things, which seem to go together. Life, mind, intelligence, and in the word you used so beautifully, agency. So you've used extraordinary sources, Barad and Alexei Yaghin, not currently recognized by the scientific community, because to you, and I think very deeply and precisely, these sources represent suggestions for principles that we could really deeply incorporate into our scientific description of reality.
This is the logic behind it all, which I think will allow it to become scientific. But one is this approach, the mind, etc., are more fundamental, and we'll start from those and then eventually build up the physics.
Yes, thanks.
I just wanted to make a point about your idea that advanced systems may set the laws of physics if this assists towards survival. I wonder if another way of putting it to some extent could be that advanced systems can set aside the laws of physics if it involves survival, for instance. A lot of the experimental research has been done on psychic phenomena, telepathy, precognition and so on. These seem to be phenomena which go against basic physical principles, but at the same time they're observed to happen, but very sporadically, and often in a situation where an organism gains in its survival possibilities because of being able to use that sort of effect. So I wonder therefore whether that setting laws of physics could also be expressed as sort of setting aside the laws of physics when necessary.
Yes, that's a very good point. That's right. It was a very interesting quote in that. I can't recall who the psychic was, but it was put off in Targ's laboratory, and the psychic was asked if he could alter the rate at which the magnetic field was reducing, and he said, right, you electrons or whatever it was, you're going to stop obeying physicist laws for a moment and obey mine instead.
Did it work?
Yes, yes.
When mine is like a comment and a question, same time. So the life is just a tunnel effect, because what we are observing, the normal life, you can go to another place where you cannot go just using the brain. You go through. So you were maybe the first to make clear, to get new effects, extraordinary effects. It's necessary to go through, not just have enough energy. The life is all is tunnel effect, and now in every day, very common, all the nanomaterials works and the special characteristics, just because all is tunnel. So we have to reverse the question. The physics is just a small side. The best, the more important is the mind that can make intuition, can go through. This is just my feeling. So your idea, that to know.
Yeah, in fact, it's a pretty commonplace thing for people to claim I have this way of getting energy from nothing. It's car that runs on water. Now, I have a theory that perhaps nature occasionally does get organised by some fluctuation to do these things, and then the fluctuation dies away and the phenomenon disappears. And we hope this will not happen with low energy nuclear reactions, which I guess are a thing of great concern here. But I think that may be a situation which will be explained in terms of these principles.
Thank you, Professor Josephson. Now, Professor Peter Rollens.